Okay, today isn't going to be very long, as I do not have much energy at all, but I've got an idea to implement a new function that is going to make these stack testers for us. So right now, whenever we want to change where a stack tester is going, we have to manually change each of these numbers. And we can't just control find and replace because we could be using these specific grids in the hard coding in our code elsewhere, and we don't want to overwrite those. So we're just going to make a little function for it. So we'll see how that goes. I'm going to take these testers out of our reset function. And actually give us a function before our reset that is called tester populate or something like that. Now, what we want tester populate to do is to basically assign all these values and colors, but based on a grid space. So I'm going to say that we first pass in a row we want to populate, then a column we want to populate, and then an amount we want to populate. So there's 3 parameters to this function. And if you take a look at here, we need to basically, anytime we assign a new value, we need to choose what color it is, what type it is. The testers will probably just be laystones by default, and we can override them if necessary. Then a stack order and a occupant amount. So let's say we know we need a stone color assignment, and we know we need a stone type assignment, and we know we need a occupied getting true. We know we need a stack control assignment, and we know we need a stack order assignment, and we know we need an occupants assignment. Okay, so so this would be the row parameter, this would be the column parameter, and then we cycle through the stone amount to iterate which member. So we can say where I gets 1, up to the stone amount. This won't exactly work as is. We need to increase our stone amount right off the bat because Lua is not 0 indexed. So we're just going to increase our stone amount by 1 so that we can do a for loop of only the amount of stones that we pass in as that 3rd parameter. And for that parameter, we need to occupy the row argument, the column argument, and the stack color. So we need to swap our color at the end of every for block. So we'll say if our stone color at that row and column if that stone color is equal to black, then our stone color will now be equal to white. And then we can say else we know we're stone color of black. So that should alternate colors of our stone color. Now, I guess we'll start off as stone color white. I don't know. It doesn't really matter. But we need to say like we need to say right here, we're just gonna say that our first stone color is gonna be white. Actually, maybe we also require a stone color for the first stone, so we could say stone color here, and then we can say if stone color is equal to white, no, if our parameter stone color is equal to white, then we give ourselves a stone color of white here in that grid. Else stone color would be black, so we need to set our stone color equal to black. Now we shouldn't need to, or no, we should still, at the end, we need to swap our stone color still, so that should be okay. Okay, so that's stone color. Now we need stone type. We can just say grid at that row column stone type. We're just going to give them all lace stones. So stone type is a lace stone. We're going to be occupied. And we don't need this in the for loop. We can actually just do this right here. Stone color, stone type. We need stack control, which is going to be based on our color. So our grid, row, column, stack control is going to get whatever stone color we are. So we can just plug in our stone color here. Stack control really only needs to be set upon the highest amount of stone. So maybe we do that outside of our for loop. Once we do, once we do all of our for loops, then we say that the stack control gets the stone color of our highest member, which yeah, we need to actually do this differently because we have members inside our occupant, so we need stone color is not a field in our occupant, It is only a field in our member. Same with stone type. So instead of doing this, we need to say dot members at index I dot stone color. So that's what we need. So okay, then same thing to here. And then this would be the stone color of our highest member. So our members table at whatever our stone amount was. Now we'd actually do this stone amount -1. We're incrementing the stone amount that gets passed in because we need to be able to do something a stone amount of times when we index at 1. Actually, this is right. We don't need to do this actually, because I think if we do a for loop for I gets 1, 2, 1, it would still run once. I think Lua kind of did that. Because it's 1 indexed, I think they do it like that. Maybe. See. So we're just going to say stone amount dot stone color. This will have the effect of putting, instead of assigning stack control every single member, we only assign stack control for the highest member that gets assigned into our members table in our for loop. Yep. Okay. So we've got stone type, we've got stack control, we need stack order. We're going to say that our stack order just gets incremented every time we place a stone in there. I believe we have our stack order set to 0. Let me see where we initialize our members and see what we do our stack order as, which is just nil. So let me see our members. Our stack order is nil. Yes. Okay, so instead of 0, so we just need to say stack order gets 1 on the first stone. Since it's nil, we can't just say nil plus 1 because actually I don't know for a fact we can't do that. I'm just assuming we can't. But I'm going to say if our stack order is nil for this occupant, our stack order is nil, then we're gonna assign that stack order to be equal to 1. Then if it's not nil, we just need to increment it. So we're gonna say stack order gets current stack order plus 1. So that should take care of our stack order. And then same with our occupants. We don't need our occupants to be in the for loop. We can just do it here. We can say that the grid at row and column dot occupants will now get assigned to be equal to the stone amount parameter. Okay. I have no idea if that's right, but we'll see. Let me just turn this off for now. Okay, never mind. I guess we'll just delete all these. Okay, so we now have a tester populate function that'll handle populating all the grids without us having to manually assign those numbers and everything. So we'll just say in a reset board, we're going to actually run our tester function. And what we're going to do is we're just going to try it at 1, 1. So there's row and column of 1, 1. Then we need, what are the other parameters? Stone color, stone amount. So starting stone color, let's say gets white. Single quotes. I don't know if it matters, but. Then stone amount, let's just say 5 stones for an example. So now let's just see if that does anything. Not what I wanted. Let's run our program. Place state 10. We need to check for equality here. Let's hope that's the only bug. Place state 8, index and null value. We don't have any rows yet. Okay, so we need to do this after we have our occupants, which don't get assigned till here. So let's just put it here. And then instead of calling it in our reset function, we'll just put it I don't know, we should put it right after we declare our function, I guess. I don't know. So we're going to declare it, then just run it. Index global nil. Grid is a nil value still. But we actually populate our grid right here. So I don't get why it's saying that. Actually, we don't run this reset board function just yet. When do we run this reset board function? Oh, we run it right there. Right in the init, we run it. So as soon as... I don't get it. I don't get it. Why can't we just init right here? At least it's a different one. Stack order is a nil. So we don't have stack order just yet. Now, where do we assign stack order? I mean, we do it here. We assign stack order right here, man. If stack order is nil, which it should have been because it crashed because it was nil. Stack order is a member field, not a occupant field. So we have to put this at our members field, at our index of I. Okay. Now, can we run it? Doesn't look like it rendered right. It says we've got 5 occupants there. It says we've got stack control of black. It doesn't say we've got stone control. It says there's 5 occupants. It's just not rendering things appropriate. So we need stack control. It's not getting signed. God dang it. Occupants get sets right, but the members don't. What if we just try one? It doesn't even render a stack order correctly on giving it 1. So what is our... I didn't think it'd be this difficult to do this, but it's proving to be. Now, stack control is a field within our occupant class. So it's okay to run it here on this occupant. And we're trying to assign it based on the members. See, it shouldn't be white. I don't get why. The stone, the tester stone should be white. It's the opposite. If the stone color we pass in is white, we're setting the members. What the fuck is happening? We give 0, does it do any stone? It shouldn't do any stone. Okay. I don't get why it's swapping the colors. And a weird stack order. Because it's looking like it's getting a stack order of 2 instead of a stack order of 1. And it's the wrong color. So what if we don't do this and we instead just increment our stack order? Can we do a nil plus 1? I don't think we can. Yeah. So we're saying, hey, if we're nil, oh, you know what? Every stack order is getting set to 1. No, that's not right. Okay. Every stack order will be nil. So we just actually need to say stack order gets I want to say instead of nil stack order we put stack order of 0 because we can't what's happening here I think is saying every stack order in our members for each loop in this for loop is nil. So it's every single stack order is getting set to 1 and then we're incrementing each stack order, which isn't right. So I want to go to our members and say stack order is actually 0. And I'm gonna say when we reset our okay, we don't actually do anything in the reset with our stack order. So now if our stack order is 0, no, I think we just want to say stack order gets incremented now by itself plus 1. Let's see if that prints us up a black stone out of stack order of 1 now. It's still printing us a white stone. Opposite. So if our stone color is white, set our member stone color to be that color. Now this stone color is actually a parameter we pass in right here as the third parameter. So why is that backwards? Stone color is equal to white. Oh, you know what? No, this should be white. I'm gonna set that first stone color to white. What the fuck? Oh, here, we swap it. So we need to swap it outside of our for loop. Not what I wanted. Okay, now this should give us the correct 84 crashing. So yeah, we need to swap our stone color. Okay. So instead of swapping, so at this point, if we just do 1, our stack, or we should be rendering this the right black tester. But we need to swap the color for the next stone if there's more in here. So we need to say that the if our current stone color was black, then our next stone color needs to get white. Otherwise, next stone color is black. Now we should still render black stone, and if we pass in white, we should get a white stone. And then if we say 2, hopefully our stack order is looking correct, which it is not. We've got 2 occupants, it's just not switching our color. So because yeah, we're swapping the dot stone color of our members, not the stone color itself. So I think we need to say it's close. There's gotta be a better way of doing this. Gotta be a better way of doing this. Gotta be a better way of doing this, man. I'm gonna restart it and try to imagine. So instead of stone color being a string, we're just gonna have it be a 1 or a 0. So what we need to do is we need to set our stone color for our grid at our row column occupant. We actually need the members at our ith position stone color to be set. So what do we need it to be set to? Well, we need it to be set to the value of our stone color. So we're going to say if our stone color parameter is equal to 1, then we want to do a white stone. So we'll say white. Else, if our stone color is 2, we would give us a black stone. Then we need to say something like we need to say that our stone color, we can do a ternary operator here. So stone color gets stone color equals 1 and 2 or 1, which is a fancy way of saying swap our stone color between 1 and 2. So let me just see if this is rendering 1 stone correctly. Looking for 1 white stone. It's not, because we're actually swapping our stone color. But actually, no, we shouldn't be swapping it. What the we shouldn't be swapping it, because we're swapping our parameter, not our actual stone color. So that's kind of confusing. If we turn this off, do we print an appropriate white stone? We don't. So what's going on? We're saying if stone color is 1, which is what we pass in, actually our stone color is now a number, not a string. So let's see if that fixes it. Okay, so 1 is a white stone, 2 is a black stone. Cool, that's working. Now we're gonna swap our stone color variable at the end of every for loop, which should, if we give us more than 1 stone, it still does not. We have 2 occupants, but it does not swap our color. Why is this happening still? If our stone color is 1, then we're a white, but we'd be a black otherwise, and we swap it here. So let me just say stone color gets 2 at this point, because we pass it a white stone. Let's pass it a white stone and then see if we switch it to black here. No, we don't. What the? I'm not sure we can change this parameter like we think we can. We should, no, yeah, we should be able to modify this parameter. I don't fucking know. Why is this so complicated? So right now we don't swap colors, but if we have 5 stones, for example, it's only rendering 1 stone, even though it knows we've got 5 occupants. Why is this so difficult? Setting our stone color of the first member based on the stone color parameter. Then we're swapping our stone color parameter. So if stone color is 1, it'll get switched to 2, and if it is not 1, it'll get switched to 1. Why doesn't that work? Because we're using this, oh, no, yeah. Because then for the next for loop, this one should execute, meaning the next member would get a different stone color. This is fucking ridiculous. Why is this not working? What am I missing? We're getting the right amount of occupants, which actually shouldn't be working because no, it is working because we pass in the stone amount. Okay. So does our stack control actually get populated here? Yes, it does. This should work, according to my brain. I'm so stumped. God damn it. What if we don't even do this? We don't even allow us to choose what stone color we're doing. We're just gonna say we start off as a white stone. Now, how would we swap this every... I mean, we would say... Why can't we do this, man? If stone color is equal to 1, set that stone color equal to 1. Otherwise, set it to black. And then we swap our stone color. So now we need row, column, and the stone amount. Not working. It's not swapping any of our members. Now, I think this might be jacked because we're running it in the init. No, because we do it after the board, which gives us our occupants and our members, so it should be right. I'm so disheartened right now. Why is this happening? We swap the stone color. We swap it right here. So let's just do 2. Let's just do 2. And see if this is working. It's not. What are we missing here? Disheartened. Let's just build it out one by one. Let's say grid. Row column. Stone type. We know is a laystone. Now we know color is going to get right. Now we need our already deleted all of our tester stacks, so I can't even test what we had. But we need stack control, stone control for our occupant, and then our occupants field. So we need to access our members table at index I. So the thing that's confusing me is we're not even rendering more than one stone, period. So there's one stone, but if we were to render 2, we should see it, but we would need a stack order. So we would say that the stack order gets assigned in a stack order in our member class. It is. So we would say that our stack order gets whatever I we're at. So let's see if we can do 2 white stones on top of one another. And we can now. So I don't think we were doing the stack order correctly. Yeah, we just want this to be I. Okay, we're rendering 2 stones. We're not swapping our color because we're not swapping it yet. So if we say stone color Stone color gets, stone color is equal to 1 and 2 or 1. So that should swap it. Swap our color. It does not swap our color. What the fuck, dude? At least we're rendering the different stack orders now, though. We weren't able to see those before. So now if we put like 10, for example, we should be able to see 10 white stones, but we're still not swapping the colors. So we are rendering 10 white stones, but it needs to swap color. So we're setting stone color to 2 upon this first loop, right? Oh, we do it right here is the problem. We reset it right here at the beginning. So we want to say before our loop, stone color defaults to 1. Then we test stone color, and then we do our ternary operator. Now it should switch. Okay. Okay, finally. Okay. We still need stack control. Oh no, we've got stack control. What else do we need? Stone control. So stone control is going to be very similar, where we're going to say stone control gets the stone color of our max stone amount. So let's see if that's working right. Now we got that. Okay, cool. Okay, so that's looking right. Okay, so now, however many testers we want, let's test a scenario. If I want, for example, I want like a 13 stack, a 13 stack, a 13 stack. Then we can manually populate a capstone here. So we can test, and then maybe like a 4 stack. So like, let's say 1, 3 is 14, 2, 2 is 30, yeah, well, yeah. Then a 2, 4. We want also a 13. We want maybe a 5 stack in our 2, 3. And then we want a capstone manually here at this 3, 3. So now that we've done this code, instead of going through all our tester stacks, we can do this fairly easily. We can say, we want a 14 stack at 1, 3. I want a 13 stack at 2, 2. I want a 13 stack at 2, 4. And then I want a 5 stack at 2, 3. And then I want a, at 3, 3, I want a capstone. So I'm going to say that our occupied gets true. And we can make another function for placing these, just not so keen on doing it right now. So we want a stone type. We want a members 1, right? So members, our members 1 stone type is going to be a capstone. And the color is going to be black. And then we want that occupants stack control. Well, we need our occupants to be equal to 1, and we need our occupants stack control to be equal to black. And we want our stone control to be equal to a capstone. So we'll eventually, probably tomorrow, we'll write a function to just place a stone just like this in any given grid, just like how we're doing a whole stack here. But for now, I'm just showing you guys the power of what we just wrote here, which is now we can kind of populate a scenario here to do testing with. So now, since this is a 14 stack, once I hit enter, this one should not be a legal move. But we should be able to move elsewhere. And actually we cannot, because we locked in 5 stones and we're surrounded by occupants that we cannot place all of our 5 stones in. So this is a scenario we need to fix, which is why it's good to debug test like this, because it wasn't very easy to get stacks like this. But in reality, there's only 21 lay stones of each character. So if this is like a 14, I mean, we technically could have this in a game. It's just probably not likely. But we don't want to go for likely. We want to go for right. So if we lock in, for example, there's a 13, a 14, a 13. So if we lock in just one, then this is an illegal move, but we could move here. So that's working. But we need to prevent us from locking in. We need to prevent us from locking in our stones like this, if there's no legal moves to place it, which is a whole nother problem. But this is what I thought of in our implementation yesterday. This is what I thought was still missing, which I was confirmed to be right. It's just easier to test it now since we don't have to manually get our stones like that. So yeah, we'll tomorrow I'm driving to El Paso, so I won't have much time, but I'll probably wake up early and we'll implement a function for placing things like this. That might be all we do tomorrow, so that we can come back ready to fix all of these bugs we're going to be finding now that we can place stacks in certain scenarios. So it was harder to implement than I thought, but this was the code. It wasn't too hard. What got me was that this stone color assignment was inside our for loop, so we were never actually switching. Our I mean, we were switching our stone color, it's just getting reset at the first line every single time in the for loop, so that's why it was hard for me to figure it out. And then we weren't actually changing the stack order to be the index of our for loop. We were doing it based on something else, I don't remember, but we got it working now. So I'll just commit what we got. Actually, before I commit, I want to just kind of go through and delete some old unnecessary code, which I knew I saw some looking through my Git, like this. We don't need this anymore. Okay. We're sitting over 1,000 lines of code, so this is currently at least in tie for the second biggest project I've ever worked on. But we're gonna say commit everything, saying added tester stack function for debugging. So now, you know, in the previous episode, I was placing all these stones, trying to get them in the right order so I can test something. Now we can kind of manually just say boop, boop, boop. And then every time we boot the game, it'll be in that same position unless we change it. And then it'll be much faster to test and iterate and fix those bugs and ultimately ship our game. So just get pushed. I'll see you guys tomorrow for another shorter day of programming.